Hey everyone, and welcome. Today, we're diving into the very first and most important concept in vector algebra. Now, I know this chapter can seem a little intimidating for a lot of students, but trust me, if we just break it down together for the next few minutes, you'll see it's actually super simple. All right, let's get into it. Okay, imagine this. You're in the middle of a game, maybe PUBG, maybe Free Fire. Your teammate yells over the mic, "Enemy 50 meters away." Now think about it for a second. Is that actually helpful, or is it kind of useless? Yeah, it's pretty much useless info. 50 meters where? In front of you? Behind you? To the left? To the right? Without a direction, that number is just noise. And believe it or not, that simple problem from a game is the entire reason vector algebra even exists. See, in math and physics, some things only make sense if you have a direction attached to them. For other things, direction doesn't matter at all. And it's because of this one single difference that we split all quantities into two big teams. All right, so let's meet the first team. We'll call them Team Scalar. Now, these guys are super easy to understand. For Team Scalar, only one thing matters: the number, the value. They just don't care about direction. A perfect example from today: think about an Instagram reel or a YouTube short that goes viral. It gets 1 million views. That number, 1 million, is the only thing anyone cares about. Nobody ever asks, hey, did those million views come from the north or from the south, right? Of course not. The number is the whole story. That's a perfect scalar quantity. And here are a few more you see every single day. Your phone battery is at 50%. Does direction matter? Nope. A bag of rice is 10 kilograms. Does it need a direction? Not at all. The temperature is 30 degrees Celsius. The price of something is 400 rupees. For all of these, the number is all you need. Direction is totally irrelevant. So, this brings us to the official definition from your NCERT book. A quantity that has magnitude only. And don't let that word magnitude confuse you. In simple terms, magnitude just means value, or the number. So a scalar is just a number. That's really it. Okay, now let's meet the second team, the one that's a bit more advanced, Team Vector. Now, this team is different. For them, the value, the magnitude, is still important, but they absolutely must have a direction too. Think about Google Maps. It's the perfect real-life example. If Maps just told you, drive 2 kilometers, you'd be totally lost. You'd be like, 2 kilometers where? But when it says, drive 2 kilometers ahead, that's perfect. You have everything you need. The 2 kilometers is the magnitude, and ahead is the direction. That combination, that's a vector. And yep, here's the official NCERT definition. A quantity that has magnitude as well as direction is called a vector. See those two keywords, magnitude and direction. You have to have both for it to be on Team Vector. Okay, so we get the idea of what a vector is, but what does it actually look like? How do we draw it on paper? You know, seeing it visually just makes the whole thing click. Let's take a look. Now, in your textbook, you're going to see this phrase, directed line segment. Sounds a little complicated, right? Don't worry about it. It's just a fancy name for a simple arrow. That's all it is. So, if you look at this arrow, the starting point, A, that's what we call the initial point. And the end point, B, where the arrowhead is, that's the terminal point. But here's the most important part. The length of this arrow, that represents the vector's magnitude. So a bigger force means a longer arrow. A smaller distance means a shorter arrow. Simple, right? All right, so we've met both teams. Now it's time to play a quick game to see if you can tell them apart. Let's see if we can become pros at spotting scalars and vectors in the wild. And to win this game every single time, you only need one secret trick. I call it the golden question. For any quantity you see, just ask yourself this one thing. Does direction matter? If the answer is yes, it's a vector. If the answer is no, it's a scalar. That's the whole trick. Okay, let's try it out on these examples. First up, 10 kilograms mass. Does direction matter? Is 10 kilograms north any different from 10 kilograms south? Not at all, so direction doesn't matter. It's a scalar. Next, 40 kilometers per hour speed. This just tells you how fast you're going, not where you're going, so scalar. But look at the next one, 40 kilometers per hour north velocity. Aha, they gave us a direction, so direction definitely matters. It's a vector. What about 20 Newton force downwards? Well, downwards is a direction, so that's for sure a vector. Now, work done. This one can be a little tricky, but work is a form of energy, and energy doesn't have a direction, so it's a scalar. And finally, displacement 2 meters west. West is a clear direction, so this is definitely a vector. See?
That one little question makes it so easy.
So you might be thinking, okay, that's a simple difference, but why is this such a big deal? Well, it's because this one small difference is the foundation for some of the biggest and coolest subjects in the world: physics, engineering, even computer graphics. You can pretty much think of vectors as the language of all these amazing fields. To understand forces in physics, you need vectors. To build a bridge, engineers are using vectors. And what's really cool is that the 3D games you play, they are built from the ground up using vectors. And yeah, as we saw, Google Maps and GPS are all about vectors. They are literally everywhere. So, the main thing to take away is this. If you can really get your head around this one core difference between a scalar and a vector, the entire rest of the chapter on vector algebra is going to feel so much easier. This is the foundation, and you've already taken the biggest step. You've got this. Okay, let's do a quick final score recap. A scalar has magnitude only. It just answers the question, how much? A vector has both magnitude and direction. It answers how much and which way. The golden trick to tell them apart is to always ask, does direction matter and what do we draw them as? Simple arrows. That's it. And I'll leave you with a final thought to take with you. Think about your own morning routine tomorrow. Before you even get to school, can you think of 3 vector quantities that you come across? Give it some thought. Because when you start connecting this stuff to your real life, it becomes truly unforgettable. Thanks for watching.